Okay, here are some more examples. The mean average temperature in Buffalo is 47.5 degrees. And the temperature fluctuates 23.5 degrees above and below this mean temperature. So what this means is this is going to be 47.5. And it's going to go above, could go above 23.5 degrees, and it could go below. Okay, so we know my amplitude is 23.5, and my midline is 47.5. If T equals 1 represents January. So when we talk about weather, we're going to talk about how it's measured. The period is going to be measured by months, so 12 months, 1 year. Okay, the phase shift, we got a phase shift of the shift, and it tells us right here where sine is 4. Okay, so before we start writing anything, we have to do some calculating. So B equals, 2 pi over 12. So this reduces to pi over 6. Okay. And then phase shift is 4 opposite C over pi over 6. So remember, if we have a bottom of the bottom, we're going to throw that here. So we get 4 equals negative 6C over pi. And what we need to do is make this a fraction, so we're going to put it over 1. Cross multiply. I'm going to kind of move this up here. So we get 4 pi equals, multiply negative 6C. We're solving for C, so we're going to divide by negative 6. And then all I have to do is reduce, so I'm going to take a 2 out, top and bottom, and I get 2 pi over negative 3. Okay, we're going to squeeze my equation right in here. So y equals, they didn't tell us if it was an inverted sine graph or not, so we're just going to leave it as sine. My amplitude is 23.5 sine. B was pi over 6, pi over 6 theta. C is negative 2 pi over 3 plus 47.5. Okay. Now, when you see the word model, what they're really saying is our equation we just wrote. So we want to know what the average temperature in March is. So March is going to be the 3rd month. So here T equals 3. So Y equals 23.5 sine pi over 6. I have to scrunch. Times 3 minus 2 pi over 3 plus 47.5. Okay. I'm going to move this so I can use the equation. So on. Okay, so 23.5 sine pi divided by 6 times 3 minus 2 pi divided by 3, close, plus 47.5. And I get 35.75 degrees. Okay. We're going to do the same thing, but this time we're going to use T equals 8. Okay. 23.5 sine pi divided by 6 times 8 minus 2 pi divided by 3, close the parentheses, plus 47.5. And I get 67.85. If you want to call that 68 degrees, I'm okay with that. Okay. Okay, and then the last type of examples you can get is what happens if they give you a whole lot of numbers. So what we're going to do is we're going to do a little dot plot almost, like we're going to plot some points, but we're not going to be exact. Okay, so this is what we're going to do. So how about this? We do it sideways. So January is going to be 73 degrees, right? So, and it's Hawaii, so it's not going to be any colder than that. Then the next number is 73. Notice I'm not doing this exact. 74, a little higher. 76, 78, 79, 81, 81, 81, 80, 77, 74. Okay. So our highest point up here was 81. Okay. Would you agree this is a cosine curve and flipped? Okay. So first thing we need midline. So we need to figure out what temperatures in between, smack dab in between 81 and 73. I'm going to go ahead and just write it right here. So you're just going to do 81 plus 73 divided by 2. You get 77 degrees. Okay, by the way, sinusoidal is just a fancy way of saying a trig function. Okay, so if you're seeing that and you're thinking we're in cosine, not sinusoidal, that's just a fancy word. Okay, so we know this is 77. Now I need to know how high up 81 is from 77, or how low 73. So you can do 81 minus 77, which equals 4. Or you can do 77 minus 73, which is 4. Okay. The period, how long did we measure? And if you see here, there's 12 months. So our period is 12 months. So let's go ahead and calculate B, because you know that's coming. So 2 pi divided by 12. Reduce it to pi over 6. Okay. We need to write an equation. So let's write an equation real quick. We'll just write it right here, right? Okay. Here we go. So y equals, remember it's cosine and flipped, so negative 4 cosine pi over 6 theta plus 77. Okay, so we're going to use t equals 1. Okay, so negative 4 cosine pi divided by 6 times 1 plus 77. And I get 73.5 degrees. Okay. August is t equals 8. So we're going to do the same thing. Negative 4 cosine pi divided by 6 times 8 plus 77. I get 79. Now here it is asking, how does our temperature compare to the actual average? Well, we know the actual average in August in Honolulu is 81. We calculate at 79. Was it pretty good? Now, remember, we're modeling something that's not, it varies. So I'd say we're 2 degrees off, but nothing to be upset about. So I would say our calculation was only 2 degrees off. Okay, so let's try May. So this will be t equals 5. And I got 80. So let's see what it is in May up here. So May it's 78 degrees. So again, our calculation again was only 2 degrees off. Okay, I hope this has helped, and I will see you in the next video.